Solving problems involving more than one right triangle is our next lesson. And that's exactly what it sounds like. Problems with more than one right triangle. Let's have a look at page 114. This one is going to be pretty brief. I'll do a couple of examples. It'll be pretty self-explanatory. They're very similar to the things that we've been doing. So we'll do this one. This is on page 114. We'll do this example and this one. And then I'll give you a few exercises for homework. This is the final concept for the unit, but I'm not going to assign a final review this week. We're just going to have the 2 recordings. Then I'll assign the final review in the following week. So, angle. It's a 47-degree angle there. And the side is 4.2. (26), and it says find the length of CD. So let's look back at the original diagram. CD is this side right here. Shit wouldn't freeze up like that. CD is this side right here. Okay, so let's label it on our sheet. So we'll do whatever we need to do to find this side. Now, we have no known side in the top triangle. So you can't solve for an unknown side unless you have at least one known side. But good news, if we solve this side, then we have the hypotenuse of this triangle and the bottom of this one. They're sharing a side, right? So we'll use this, we'll solve this triangle for this side, then we'll have a known side here. So let's have a look. This is the hypotenuse of the triangle. We have a 47-degree angle up here, and our known side is 4.2 is opposite of this angle. We're using the sine ratio for the first time today, opposite over hypotenuse. Sine 47, 4.2 over x. Sine 47 degrees equals 4.2 over x. And this simply is a dividing question. 4.2 divided by sine of 47 is equal to 5.7. So now we have a known side and a known angle. We can solve for this side. So the known side for this triangle is the middle side, and we are trying to find the hypotenuse. So there's our known angle, 26 degrees. The known side is right beside it, and the unknown side is the hypotenuse, right? Because there's the right angle, there's your hypotenuse, right? So the long side. This is right beside the angle adjacent. This is the hypotenuse. So we're using cosine. Cosine 26 degrees equals 5.7 over x. So again, we're going to be dividing. (5.7) divided by cosine 26. 6.3. There we have it. There's our unknown side. Let's just double check. Oh, they only did the 5.7. They didn't even do the 6.3. But that's okay. We did it. We're good. Yeah. Okay. Let's have a look at the triangle on the other one on page 114. So what's this look like? A couple of right triangles smooshed together thusly. It says calculate the length of xy. Now let's have a look at what xy is in the diagram. That's here. The slanted side of the small triangle, the hypotenuse. The small triangle. So our goal is to find the length of this side. Very similar to the previous problem, we do not have a known side as part of this triangle, but we can solve for this one that the two triangles share. So we have a known angle, and the side here is opposite of the angle, and we know what our hypotenuse is, 8.4. So we're going to use sine, once again. Sine of 20 degrees equals x over 8.4. This time it's a multiplying question because x is on top. Sine of 20 degrees times 8.4. $2.87. 2.9. So now we have a known side, and we can go ahead and solve this triangle. Again, this is the hypotenuse, the long side that we're trying to find. 22-degree angle here, and the known side that we've now found is right beside the angle. It's not opposite, it's not this one, it's right beside it, it's adjacent, right? So we're using cosine this time. Cosine of 22 degrees equals our known side of 2.9 over x. So now we are dividing. 2.9 cosine 22 . $3.1. So that's the side here, 3.1. I'm going to keep the homework for this one pretty short. We're just gonna, those two examples will be sufficient for this concept. And I'm just going to give you one question. Page 118. Number 3. That's it. Just the one. And here we have a whole bunch of examples of two right triangles beside each other. And each time you're asked to find side JK, which in this case is here. In this case, it's over here. In this case, it is over here. And over here. Let's let's do, I think we'll do one of these. We'll do 3C together. Okay? We'll do 3C all together to solve for side JK in that one. I think I have enough space left on the paper here. So we're doing 3C together, and then you will do, your homework will be to do A, B, and D. We're going to do 3C together just to make sure that we have done enough examples of this concept. We have a 3 and a 35 and a 30 for our angles, and we're trying to find side JK, which is this side. We have a right angle up there. So what we need to do is find, like, this is not a right triangle, but the big one is. Das ganze Ding zusammen is a right triangle, und das kleine da is a right triangle. So let's find the entire side first. Okay, der ganze Seite da müssen wir finden. Okay, we have a 30 and a 35 down here. So if we put them together, they'll be 65. So essentially, you've got a 65-degree angle here, and you've got a side of 3. So the side we're trying to find is opposite, and the known side is adjacent. That's tangent. Tangent 65 x over 3. Tan 65 times 3. .4. So the entire side is 6.4, but we want to go from here to here, right? So what we're going to do is find the length of the small right triangle and then subtract. So inside the small right triangle we have a 35-degree angle, and we still have the side with a length of 3. Once again, it's opposite over adjacent. Tan 35 x over 3. Tan 35 times 3. .2. So, our last, oh my, oh goodness, that does alles nicht sehen, right? Stupid. What am I going to do now? I'll grab a fresh sheet and do this question again. No. And 3. So again, we're going to solve the large triangle. So put 30 and the 35 together. We get a 65-degree angle. We want to solve the entire length, the side. So 65, this side is opposite, and our known side of 3 is adjacent. That's tangent. Tangent 65 x over 3. You can see immediately that it's a multiplying problem. Tan 65 times 3. $6.4. Tangent of 35. Now we're going to the smaller triangle. 35 degrees. The side we want to get is opposite, this one here. If we do that, and we still have a known side of 3. So tangent of 65 degrees is x over 3. Whoops, I used the wrong angle, sorry. It's of course tangent of 35. This is the klana sa angle lite grusa. 35, sorry about that. Tangent of 35 times 3. $4.3. So again, this is 3C. You will do A, B, and D. If you look at the questions, they're going to have similar procedures to the ones that we just did here. If you need any help doing them, you'll need to let me know. So to remind you again, your homework is page 118, number 3, A, B, D. And the one A, B, D, and the one that we did here is 3C from that page. All right, that's it for this recording.